Hello everyone and welcome to first problem of general force system. Now what is general force system? So general force system is a force system in which forces are neither parallel nor concurrent. Such force system are called as a general force system. Now here one lever is provided and on that bell crank lever some forces are acting, and for that given force system we have to find magnitude, direction and the point of application. So we can say magnitude, direction and last is what? Location of the resultant with respect to point O. So here I'll find location with respect to point O. As we know very well that first step while solving the problem of either concurrent force system or general force system is common, and it's what? It's we have to resolve the force along the x direction and y direction. So here you can see that very first force is this 500 Newton acting in downward direction. So to this I can resolve first along horizontal and along vertical. Here I can say that this will be 500. Now since this 500 Newton is making 60 degree with the horizontal component will become cos component, so vertical will become sine component. So that's first thing. This is my first force. Second force is 1000 Newton. No need to resolve it because it's already vertical force. Next is 1200, again it's vertical force, no need to resolve it. And then finally 700 Newton, it's along x-axis, so that's horizontal force, so no need to resolve it. So forces that are horizontal or vertical, no need to resolve it. Only forces that are inclined to x or y axis, I have to resolve that force. So I'm done with step number 1, where I have resolved all the forces of the given force system. In step number 2, I have to calculate the summation of all component acting along x-axis. So now I'll only consider x component. So I'll only consider horizontal forces. While considering this, remember that forces that are acting towards right hand side will be considered as positive. So forces that are acting on left hand side will be negative. That's my assumption. Let us start with horizontal forces. So first is a 500 cos 60. Now you can see that this 500 cos 60 is acting on the right hand side. So I have considered it as positive, 500 cos 60. This is vertical force, so no need to consider this. Again this is vertical force. There is one more horizontal force, that is 700 Newton. So here I'll write 700. But you can see the direction of the 700 Newton, it's acting towards left hand side, and forces that are acting towards left hand side I'll consider it as negative, so minus 700. Now after solving this I'll get answer as minus 450 Newton. This again minus sign indicates that force is acting on the left hand side. So at final step I'll write 450 Newton acting towards left hand side, and that is my step number 2. Here I have calculated Rx, or I can say summation of Fx. Same way we will go for y component and in step number 3 I have to calculate summation of all components acting along y axis, and here upward forces will be positive, downward forces will be negative. So let us start with first force, that is 500 Newton. So vertical component of the 500 Newton is what? 500 sine 60 acting in downward direction. Then here I will say 500 sine 60, and minus sign indicates that it is acting in downward direction. Next is 1000 Newton, again acting in downward direction, so minus 1000. And then 1200 Newton again in downward direction, so minus 1200. On solving this I'll get answer as minus 2633.01 Newton. So I can say that summation of Fy, to which I also call it as Ry, is 2633.01 Newton acting in downward direction, because this negative sign indicates that summation of Fy is in downward direction. So with this, in step number 1 I have successfully resolved the forces along x and y axis. In step number 2 I have calculated all the components that are acting, summation of all the forces that are acting along x-axis. In step number 3, I have calculated summation of all forces that are acting along y-axis. Now we will go for step number 4. And in step number 4, I have to calculate magnitude of the resultant force. We know formula for this is R is equal to under root of summation of fx square plus summation of fy square. When I'll put this value, whether you are considering this as minus 450 or minus 2633, it doesn't matter, because finally we have to square this term. So whether you consider plus or minus, when you will go for square, you will get answer as positive. And when you put the value under root of 450 square plus 2633.01 square, I'll get answer as 2671.19 Newton. And this is resultant. This is magnitude of the resultant. Then I'll go for step number 5, and that is I have to calculate theta. That is nothing but what? Direction of the resultant. So I have to calculate direction, means I have to calculate angle of R, that is resultant, either with respect to x-axis or with respect to y-axis. Then that is equal to tan inverse of ry by rx. Can I say this? This is tan inverse of summation of fy by summation of fx. But then here remember one very important thing. Always take summation of fx and summation of rx, summation of fx or summation of fy as positive value. That's very important. Okay, because here I am measuring this with respect to the x-axis. So when I'll put value of fy as 2633.01 and fx as 450 Newton and tan inverse of this ratio, then it will give me answer of theta as 80.31, so 80.31 degrees. That's what I'll get answer. That is what? 80.31 degrees. Then we will go for step number 6, that is location of the resultant. Now I have to locate that force R. Okay, so what I have done, so first I am done with magnitude, I have calculated R. Then I am done with direction, I have calculated theta, and then I'll go for point of application with respect to O. So I have to find x distance and y distance of resultant with respect to point O. For that, we know that we will be using Varignon's principle, and here we have to consider forces that are acting in anti-clockwise direction are positive. So I'll calculate summation of MO, that is summation of moment produced by all forces about point O. So I'll consider about this point O. Okay, so let us start with first. So to this 500 Newton, can I resolve it here? I have already resolved it is as 500 sine 60, and then here 500 cos 60. Okay, now when I want to find moment produced by these two forces, then very first 500 cos 60, you can see line of action of 500 cos 60 is passing through point O. So 500 cos 60 will give you what? Zero moment. How it's giving you zero moment? Because its moment is force into perpendicular distance, and when force is passing through the point about which I am taking moment, then distance between force and that point will become zero, because it's passing through that point, and 0 into that force will give you answer as 0. So no need to consider this 500 cos 60. What is left? 500 sine 60. So first here I'll write 500 sine 60. Now I have to find distance. You can see that 500 sine 60 is a vertical force, so I have to consider horizontal distance. So what is horizontal distance between 500 sine 60 and point O? So basically I'm talking about this distance. You can see that this distance is 150 mm plus 150 mm, that is 300 mm. And since I am calculating summation of MO in terms of Newton meter, I'll write 0.3. I have converted mm into meters. That's first. Now I'll go for second force, and second force is this 1000 Newton. So you can see here 1000 Newton acting in downward direction. So first I'll write force. So first here I'll write 1000. Okay. Next I'll go for its distance. What is, now force is vertical, so what is horizontal distance between this force and point O? Then you will find that it's 150 mm. So I can write 0.15 meters. So here 1000 into 0.15. Now let's see what moment is produced by this force. You can see that when I apply this force, it will try to rotate this beam in anti-clockwise direction. Same applies here. When I'll apply this 500 sin 60, it will try to rotate this beam in what? Anti-clockwise direction. And anti-clockwise, here you can see that anti-clockwise I have taken as positive. So I have considered this as plus and this as also plus. So these both forces are producing moment in anti-clockwise direction, and hence I have considered that both moment as positive. Next we will go for third force, and that is 1200 Newton. You can see this 1200 Newton. So that is a vertical force. Since the force is vertical, I have to find this horizontal distance. Okay. So for that I have to redraw this triangle. So you can see this smaller triangle I'll redraw. Here you can see that this is 1200 Newton and this is point O. So basically, since the force is vertical, I have to find this horizontal distance. Now to find this, I'll complete this triangle, and here you can see that this angle is given as 60. Okay, and so I'll mark this angle as 60. Okay, this hypotenuse is given as 150 mm. So here I'll write 150 mm. Okay, and what I have to find? I have to find this horizontal distance. Okay, then here can I say that I have hypotenuse and I want adjacent side, then I have to go for cos theta. Cos theta is what? Adjacent upon hypotenuse. Okay, so can I say cos 60? Okay, what is adjacent? So that's what I have to find. Okay, and what is hypotenuse? 150 mm. So I can write 0.15 because I am finally considering moment in terms of Newton meter. So can I get required length as 0.15 cos 60? Okay, so you can see that what is the length? 0.15 cos 60. So you can find that 1200, that is basically a force, into perpendicular distance, that is 0.15 cos 60, that is what? Your moment. And then finally we will go for its direction. Then you can see that this force is producing moment in what? Anti-clockwise. This is producing in what? Clockwise direction, because here you can see this is a force and it will try to rotate it in clockwise direction. So for that clockwise direction, I have to consider this as minus. Okay, and then finally here you can see 700 into 0.3 sin 60. It's for this final force 700. So this is a horizontal force. I have written 700. For horizontal force, I have to find this vertical distance. Okay, then again I'll draw this triangle. So now I'll draw this entire triangle. Okay, and this total length of the triangle is 300 mm, 150 plus 150. And now since the force is horizontal, I have to find a vertical distance. Then I have to find this vertical distance. I'll put question mark over here, and this time I'll go for, since I have hypotenuse and I want to find opposite, then I can go for sin theta is equal to opposite upon hypotenuse. So can I say sin 60 is equal to, opposite is what I have to calculate, that is question mark, and hypo is what? 0.3. So can I say whatever length I required is 0.3 sin 60, and that's why I have written here 700 into 0.3 sin 60, and this will create moment in anti-clockwise direction. So I have considered this as positive. Now when I add all this moment, final answer I am getting is 371.77 Newton meter. Since I am getting answer as positive, that is 371.77 Newton meter, can I say this overall total moment is in anti-clockwise direction, because I'm getting answer as positive. Now we are moving towards our final step, and by applying Varignon's principle we have to locate resultant. Okay, so for locating resultant, remember we have three formulas. Okay, so very first thing is distance, next thing is x, and third thing is y. So when I want to find distance, what Varignon's principle I'll apply? I'll apply summation of MO is equal to R into D. So this R stands for what? Resultant, and this D stands for perpendicular distance. So say this is resultant R, okay, and if I want to find distance D here, then this will be the perpendicular distance D. This will be what? Perpendicular distance D. Whereas if I want to find its x component and y component, so here I have written x component, then again I will use same, summation of MO is equal to, okay, what I want is x is equal to something into x. Okay, now what I'll put here, see, moment is force into perpendicular distance. When your perpendicular distance is x, what is perpendicular to x is y, then I'll put summation of Fy. And same way if I'm going for y, if I want to calculate y intercept of the resultant, then summation of MO is equal to, what I want is y, what is perpendicular to y, then is x, then summation of Fx. So using these three formula, we can calculate either perpendicular distance of resultant from the given point, or x intercept and y intercept. In this sum we are going for x intercept and y intercept. So for x intercept, summation of MO is equal to summation of Fy into x. So can I say that x is equal to summation of MO upon Ry? So summation of MO is what? This I have got as 371.77, and then Ry, I have already calculated Ry. So here you are getting value of Ry 2633.01, and that's how you will get answer as 0. That is x is equal to 0.141 meter. And then same way when you will go for y, summation of M upon Rx, and you will get answer as y as 0.826 meters. Now let us plot resultant. Okay, so for plotting resultant, first I'll draw this y-axis, centroidal y-axis, and x-axis. These are basically absolute axis. Okay, what answer of Fx you are getting? Fx is along the negative x-axis. So basically this is your summation of Fx. Okay, Fy is again you are getting along negative y-axis. So this will be your summation of Fy. This is quadrant 1, this is 2, this is 3, this is 4, and from that you can say that your resultant lies in the third quadrant. So here I will draw resultant R, that is making angle theta with respect to x-axis. So from here you have got direction of the resultant. Okay, and that resultant direction we can show over here as x component and y component is given. So here you have shown that this is a resultant. Okay, so this is a resultant R with this as y component and this as x component. So main intention behind drawing this diagram is you will understand how we are getting this direction of the resultant. So first I have located that it's in the third quadrant, because summation of Fx and summation of Fy both are negative, and then to give angle theta with respect to x-axis, from that you will get this diagram. So what we have done in this problem, first we have resolved the forces along x and y component. Second, we have calculated all the forces or all the components that are acting along x component, x axis. Then we have calculated all the components that are acting along y direction, then magnitude of resultant, direction of resultant, and then using Varignon's principle we have calculated or we have located the resultant. This type of problems are very important from exam point of view. I hope you have understood this sum. Thank you.